Exercise 1.11. Calculate the resultant capacitance for each of the following combination of capacitors. Now here, first combination, this is diagram A. Okay. Now here there are three capacitors. Two are connected in parallel, one in series. Now you can see here capacitance are given as C0. All the capacitance are given as what value? Z0. For our convenience, I am going to name it as 1, 2 and 3. Okay. Now, how to find out the equivalent capacitance? Okay. Now, in the diagram, capacitance 1 and 2 are connected in parallel. So, we can write capacitance 1 and 2 are connected in parallel. Okay. So, for that we can write Cp is equal to C1 plus C2. What is the value of C1? That is 1. That is C0. Here it is C0. So, 0 plus C0, that is Cp is equal to 2 C0. Okay. Now, I can draw an equivalent diagram for this. So, what is the equivalent diagram I can draw here is, this can be drawn as, now these two can be replaced by a single capacitance. So, how to draw it is, here already one capacitance is there. Okay. So, this is your C0, this is your capacitor number 3. Okay. And now, the other two capacitance, equivalent capacitance can be drawn as Cp. So, what is the value of Cp? That is 2C0. Okay. Now, these two are connected in what? Series. These two are connected in series. So, we can write capacitance 3 and Cp are connected in series. So, what you can find it out? 1 by Cs is equal to, okay, 1 by Cp plus 1 by C3. That is 1 by Cs is equal to 1 by 2 C0 plus 1 by C0. Taking LCM, we'll be getting as what? 2C0. Here it is 1 plus 2. So, 1 by Cs is equal to 3 by 2C0. So, Cs is equal to 2C0 by 3. Now, this is your equivalent capacitance. This is your what? Equivalent capacitance. So, we can write the resultant capacitance for the entire circuit is 2C0 by 3. Now, we will go for the second diagram. In the second diagram, 4 capacitance are there. Here 1, 2, 3, 4. Okay. Each are having capacitance value C0. Okay. Now, here for our convenience, we are naming it as 1, 2, 3, 4. Here 1 and 2 are in series, 3 and 4 are in series. 1 and 2 are in series and 3 and 4 are in series. So, we can write capacitance 1 and 2 are in series. Similarly, capacitance 3 and 4 are in series. So, each are having the same value. So, the equivalent capacitance will be same. Okay. So, I can find it out 1 by CS1 first. So, the equivalent capacitance of these two is 1 by CS1. That is 1 by C1 plus 1 by C2. Okay. So, what I will get it? 1 by C0 plus 1 by C0. So, 1 by CS is equal to, what I'll get it here, it is C0, 1 plus 1. So, it is 2 by C0. So, 1 by CS1 is equal to 2 by C0. So, CS1 is equal to C0 by 2. Okay. Similarly, for what? 3 and 4. Therefore, CS2 is also what? C0 by 2. Okay. Because all are having what? Same value. So, when you find it out, here also CS2 is equal to C3 plus C4. Then all the other things will be what? Same. So, the same value only you will be getting for CS1 and CS2. Now, I can draw the equivalent diagram for this. Now, this is CS1 and this is what? CS2. Okay. Now, CS1 and CS2 are connected in parallel. So we can write CS1 and CS2 are connected in parallel. So what is your equivalent capacitance? Cp is equal to CS1 plus CS2. So what is your CS1 value? C0 by 2 plus C0 by 2. That's nothing but what? C0. That's nothing but what? C0. So the resultant capacitance is what? C0. So we can write resultant capacitance is equal to what? C0. Now, the third diagram. Here, this is your third diagram. Okay. So, this is how the capacitors are arranged. So, for our convenience, we are taking 1, 2 and 3. Now, we can redraw this diagram. Here, all the three are parallel only. So, we can redraw. We can redraw the diagram like this. So, this is 1, 2, 3. Now, you can easily understand how it is parallel. Okay. Now, all the three are connected in parallel. So, we can write capacitors 1, 2 and 3 are connected in parallel. So what is your equivalent capacitance? Equivalent capacitance is Cp is equal to C1 plus C2 plus C3. All are having equal capacitance value as what? C0 plus C0 plus C0. So what is the value? 3 C0. So your resultant capacitance is what? 3 C0. Now the next diagram. Now here 4 capacitance are connected like this. Okay. Now this is named as C1, C2, C3, C4. Now we'll go for finding the equivalent capacitance. Here these two are connected in series. These two are connected in series. Okay. So if you draw a straight line, it will be these two are connected in series. Okay. So we can write C1 and C3 are connected in series. Okay. So the equivalent capacitance we can take it as 1 by CS1. That is 1 by C1 plus 1 by C3. So what is CS1? CS1 is equal to, taking the LCM here, you will be writing 1 by CS1 is equal to C1 C3 by C1 plus C3. So CS1 is equal to C1 C3 by C1 plus C3. Now C2 and C4 are in series. So C2 and C4 are in series. So what will you get here? CS4 is equal to C1, C2, C4 by C2 plus C4 by the similar way. Okay. So C2, C4 plus C2 plus C4. Now the equivalent diagram is this. Okay. Now we can write CS1 and CS2 are in parallel. So we can write your equivalent resistance as Cp is equal to, what is your CS1? C1, C3 by C1 plus C3. Here it is C2, C4 by C2 plus C4. Okay. Now taking LCM, what will you get here? Here it is C1 plus C3 into C2 plus C4. So you'll get C1 C3 into C2 plus C4 plus C2 C4 into C1 plus C3. Now this can be expanded. You can write C1 C3 C2 plus C1 C3 C4 plus C2 C4 C1 plus C2 C4 C3 divided by, what will you get? C1 plus C3 into C2 plus C4. Now this is your resultant capacitance. This is your what? Resultant capacitance. Next diagram is like this. Okay. So here 5 capacitors are connected. Now we can redraw this diagram like this. Okay. So and we are renaming it as 1, 2, 3, 4, 5. Now here capacitor 1 and 2 are in series, 4 and 5 are in series. So we can write capacitors 1 and 2 are in series. So 1 by CS1 is equal to 1 by C0 plus 1 by C0. The values are 1 by C0 plus 1 by C0. That is how much? 2 by C0. So 1 by CS1 is equal to C2 by C0. Okay. So what is CS1? CS1 is equal to C0 by 2. Similarly, capacitance 4 and 5 are in series. So what you can write, 1 by CS2 is equal to 1 by C0 plus 1 by C0. That is again 2 by C0. So CS2 is equal to C0 by 2. Okay. Now we can go for drawing an equivalent. Now here CS1, 3 and CS2 are in parallel. Okay. So we can write CS1, CS2 and capacitor 3 are in parallel. So we can write Cp is equal to CS1 plus CS2 plus capacitor 3. Okay. So what is your capacitor 3? We can write it as capacitor 3. That is what is CS1 value? That is C0 by 2. Here this is C0 by 2. This is how much? C0. So when you take the LCM, what will you get here? Here these two are what? C0. 1 by 2 plus 1 by 2 is 1. C0 plus C0. So what value you get? 2 C0. So the resultant capacitance is how much? 2 C0. So this is how different circuit will be given. You have to find out the values of the resultant capacitor.